for this session, which is matrices, geometry, inequalities, and speed time graph. So for this session, we're going to look at matrices, geometry, speed time graph as our priority sessions, our priority topics. And then for inequalities, there's a component from coordinate geometry in inequalities. And so I've just realized that yesterday we were meant to do coordinate geometry, but we didn't. So initially I lined them up this way so that after doing coordinate geometry we would have been ready today to look at inequalities. But since we didn't do coordinate geometry, we are going to marry these two for tomorrow's session. So tomorrow, after we look at coordinate geometry, we'll look at 3 tomorrow. We'll look at coordinate geometry. We'll also look at the calculus that I showed you yesterday, the one where you're asked to find the equation of the curve, the equation of the normal to the curve, the equation of the tangent, because those also have a component of coordinate geometry in them. So tomorrow at exactly 20 hours, we're going to look at coordinate geometry, calculus, and inequalities. Yeah, so instead of us looking at inequalities today, it will be easier for us to understand inequalities when we know part of coordinate geometry. So meaning in this session we're just going to look at matrices, geometry, and speed time graph. Right, I think we have waited long enough. We can now start. So we're going to start with matrices, paper 1. So matrices paper 1 is actually very simple. They usually just ask you to find the transpose of a matrix, and then they also ask you to multiply some matrices. Okay, but before we go into that, we need to understand a few things about matrices. Okay, so the first thing is that we need to be able to tell the difference between rows and columns. All right, so when you have a 2 by 2 matrix, by the way, let's say you have this matrix, you have A there, you have B there, you have C there, and you have D here. Okay, moving up, okay, from up going down, meaning these two, this is called a column. Again, this is also called a column. So you're moving down, you have A and then you have C, that is your column there. So meaning how many columns do we have? We have 2 columns, 1, 2. all right, and then rows move from left to right, okay, in this direction like that. So we have this row and that row. So meaning how many rows do we have? We have 2 rows. So now the order of a matrix is given by row times column. Okay, row by column. This is pronounced as by and not times. So meaning this one here is a 2 by 2 because it has 2 rows and 2 columns. So that's how come we are going to refer to it as a 2 by 2 matrix. Okay, another example you can have is something like this. You have 1 there, you have 2, 3, 4, 5, 6. Okay, how many columns do we have? We have 1, which is 1, 2, 3. That's the first column, and the second one is that one, 1, 2, 4, 5, 6. Okay, how many rows do we have? We have this first row, this second one, and the third one. So the first row is 1, 4, second row 2, 5, third row 3, 6. So what's the order of this matrix? Remember, the order is given by this row by column. So you count, how many rows do I have? 1, 2, and 3. So I'm going to write 3 by. How many columns do I have? We simply have 2 columns. There is this one here and that one. So that's going to be a 3 by 2 matrix. Now there are scenarios where students get confused. Okay, let's say you have something like this. There's a 3 here. Okay, how many rows? Okay, it's easy for us to say there is only 1 column here, But how many rows do we have in this matrix? So simply because you have, by the way, these numbers are called entries. Okay, so simply because you have one entry per row doesn't mean it doesn't count as a row. It still counts as a row. So you have how many rows? You have 3 rows. Okay, please take note. Even when you have something like this, okay, you have 1 0 4 like that, these still count as columns. Okay, meaning you have the first column here, second column, third column, and then this is your row. So meaning the order of this matrix is going to be how many rows? Just 1. So it's going to be 1 by how many columns? 1 2 3 columns. That would be the order of that particular matrix. That is that. Now when it comes to multiplying matrices, you always multiply a row by the column. So let's say for example you had a 2 by 2 matrix. Okay, you had matrix A given to you as 1 0 4 1. Okay, and then you also had matrix B given to you as let's say 0 2 1 5. Okay, how do you multiply these two matrices? Okay, so to multiply two matrices, we can simply put these values together, matrix A and matrix B. This shows that we're multiplying matrix A with matrix B. Alright, this is different from this one. Okay, so you list the matrices based in the order the matrix their names are listed. So A is in front, meaning matrix A has to be in front, followed by matrix what? Matrix B, like that. For us to find BA, we need to list B first. So it's going to be 0 2 1 5, and then times matrix A, which is 1 4 0 1. Because the examiner can give you these matrices in this order. They give you matrix A first and then matrix B in the question, and then instead of asking you to find matrix AB, they will ask you to find BA, meaning you need to swap them when listing them, when multiplying them. So that is why that is important to do. I once did this for my students and they failed for it. I've not seen any question that has been phrased that way yet, but you don't know. If I could think about it like that, the examiner can also think about it like that and trick you. Okay, I'll show you an example. Let me check. There's a question I put up that has something like that. Let me just see. Okay, this one here. They've actually done it before. So we are used, let me give you the general. You've seen here, they've given us matrix A first, followed by matrix B, and they're asking us to find what? AB. So you, when you're copying, you're just going to say matrix A times matrix B. This is usually the norm. You go to the next one again, it's the same thing. They'll give you matrix P first, matrix Q first, and then they ask you to find PQ. So you just say this matrix times that matrix. Now, they know people don't like patterns. Again, they'll give you the same thing. Okay, they focus on patterns. Matrix A, matrix B, ask you to find AB. So if you solve a couple of these questions, you get used to the pattern. It's usually the first matrix times the second matrix, but here they switch things around. Okay, they gave us matrix M first, right? Then matrix N, and then they asked us to find NM, meaning it's supposed to be this matrix times the other matrix. So examiners will get you used to a pattern and then change the pattern, and if you're not careful, you'll fall for the odd ways. All right, so make sure when multiplying you figure out the correct order, which matrix is supposed to be in front and which one is supposed to be behind. Okay, so now I was talking about multiplying matrices. I said you need to multiply them using the format rows by column. So it will be this row by that column, okay, and then this row by the same column. So all the rows will multiply with the same column. That's when they progress to the other column. Again, it will be this row here by that column there, and again this row by the same the same column. So how do you then multiply? You're going to say this, okay, 1 times 0 plus 0 times 1, like that. This guy times that one, and then that one times that one. Again, you're going to follow the same principle. This one here times that first value, this one times this value here. So the shortcut is this. When you have two rows, just know that these guys here are going to multiply with the same value, which is a 0 here, and these ones are going to multiply with the same value, which is a 1. If you come to the second column here, these guys here will multiply with that value, and then these guys here will multiply with that value. It will make more sense when I start showing you how to solve these questions. Then I'll show you a shortcut of how to quickly figure out how to multiply these matrices. 2 by 2 matrices are quite easy to multiply. The ones that are tricky to multiply are matrices with different orders. Let's say 2 by 2 by maybe 1 by 3, something like that. Okay, although I think those orders were not correct, but basically matrices with different orders, those are the ones that students usually get to have problems multiplying. Right, okay, so that is that about multiplying matrices. I'll tell you more about how to do it as we get to deal with different types of matrices. I've selected a couple of different types of matrices, so we'll be pretty much done by the time we'll be finishing this session. Okay, then when it comes to the transpose of a matrix, this is the simplest question on matrices. Okay, so transpose is denoted by a T which is placed as a superscript. Okay, so when you have something placed somewhere there, like a power, it's called a superscript. When it's down here, it is called a subscript. So the T is placed as a superscript, and that simply denotes a transpose, because sometimes they will not say find the transpose, they'll just say find, then they do it this way. So just know that this is asking me to find the transpose of a matrix. So to find the transpose of a matrix, get the original matrix. Let's say this is the original matrix, okay, which is 2, 4. Okay, to find the transpose of a matrix, you simply swap the rows with the columns. Your rows become your columns. So in this case, it will just change to this. Okay, 2, 4, like that. The rows become columns. What is a column here? It is 2, 4. In this case, the rows are the ones that have become columns, so it is 2, 4 here as your rows. All right, what was the row in the first matrix? The row was this one here, which is 2, 4, in that order. Now it has become a column, which is 2, 4. Another thing for those that would like to confirm whether what you've done is right, simply write down the order of your first matrix. How many rows do we have? We have 1 row here. Okay, and how many columns? We have 1 and 2. So it is a 1 by 2. The transpose of this matrix should be the opposite order of this one, so meaning it's supposed to be a 2 by 1. And you can see we have 2 rows and 1 column. So that is how come you can be able to tell that I've done the right thing. So even if you have something like I think this is the simplest question, and many people actually get this one right. Okay, let's say you have a 2 by 3. So you have 2, 0, 4, -1, 5, 2. Okay, to find the transpose of this one, you're simply going to swap them around. So it's a 2 by 3, meaning it will change to a 3 by 2. Okay, so the first row will become the first column, so it's going to be 2, 0, 4. The second row will become the second column, -1, 5, and a 2. That is how you find the order, the transpose of a matrix. Okay, so at this point I think we can now proceed to the questions. Do we have any questions at this point? Is there anyone with a question before we proceed to the questions, the exam questions? Okay, since we are good to go, we go to matrices. Exam questions. So the first one is coming from 2022 paper 1, was written by the grade 12s. and the question says the matrix M is equal to 1 5 2 7 and the matrix N is 0 1 2 0. Find M transpose. You've seen the way they phrased it. The T has been placed as a power, meaning they're simply asking us to find the transpose of matrix M. So the first thing you're going to do is write down matrix M. What is matrix M? It is this one here, which is listed like this. We have 1 2 5 and 7, like that. Now to find the transpose, we're going to now say the rows become columns, right? So what is the first row? The first row is this one here, which is 1 5, so it's going to become the first column 1 5. The second row is 2 7, so it's going to become 2 7, and you are done. That is your transpose of that particular matrix. I hope that is clear. Remember, if you have a question, you can simply raise your hand by pressing the hand icon on your phone, on your screen, or you can type in the chat. So if I don't see any of those, I'll presume that there is no question. Alright, we proceed to the next one. Okay, where they're asking us to find NM. Remember, I said when they list the matrices like this, they're simply asking you to multiply the matrices. Okay, you're going to multiply matrix N with matrix M. So meaning matrix N should be in front of matrix M. So you're going to say NM is equal to, what is N? Remember, we're supposed to follow the order. So N is this one here. So I'm going to say 0 1 2 0. Please take note that there has to be enough spaces between the entries. You've noticed there are enough spaces. Even here there are enough spaces. Okay, you don't have to write them as if it's one number like 2 0. No, you have to leave enough spaces to show that this is a different entry and the other one is also a different entry. That is very important. So we've written matrix N. Now we need to write matrix M. Matrix M is this one here, which is 1 2 5 7 1 2 5 7. Okay, so I'll show you a shortcut on how you can actually multiply these matrices. Because usually students get to have challenges multiplying the right values. Okay, so if in your row you have 2 entries, you have 1 2 or more entries, you simply need to put a plus after multiplying each entry with another entry. So meaning we're going to say 0 times 1 plus 1 times 2. That is because in the row we are multiplying, we have 2 entries there. Okay, if you only had 1 entry, then there will be no need for you to put a plus. Please take note of that. If you have 2 or more entries in your row, you need to add a plus after multiplying each entry with another entry. Okay, so meaning here we're going to say 0 times 1 plus 1 times 2. Okay, so we're going to say NM is equal to, we said, let me just clear up. We said the first one times the first one up here, so 0 times 1, then we add a plus because we still have another entry in that row, 1 times the bottom one. Okay, 1 times 2. Then at this point you proceed to the next. Okay, let me see how can I simplify this. Okay, we can proceed to the next one. Let's multiply with this other column now, this one. So we're now going to say 0 times 5, 1 times 7. And just clean up. So 0 times 5 plus 1 times 7. But you need to leave some space here. Okay, so it's going to be 0 times 5 plus 1 times 7. And then you can close here. So at this point, this is now what you're going to do. This is a shortcut I was talking about. Instead of again you go to the bottom row, and you start multiplying 2 times 1 plus 0 times 2. Again you go 2 times 5 plus 0 times 7. This is what you can do, okay, to simplify things. Simply check each column in your first matrix. This is 0, 2. Just say 0, 2 times the same value being multiplied with up here plus. You go to the second column. This is 1, 0. So you have 1, 0 down here times the same value being multiplied with up there. Okay, you go to the other column, which is this one here. Same principle again. You have 0 there, you have 2 there. So you already have 0, so just put a 2 there times the same value being multiplied with up there. Okay, plus. Go to the second one. 1, 0. You already have 1 there, so just put 0 times the same value there. So here's one thing you can check to see whether you have plugged in the correct values. After the multiplication sign, you should always have the same numbers like this. Okay, 2, 2, because you know each value is multiplying with the same value on the other side. You can see there's 5, 5 there, there's 7, 7. So whenever I'm marking this question, I'll simply check after the multiplication sign, am I seeing the same values? If I just see different values, I know to say this question, no matter how well it will be solved, it will end up being wrong. So those are some of the checks and balances you can do to make sure that you're doing the right thing. Remember, there is no room for mistakes here. Okay, so in order for this to work, you have to make sure that these values on top here are multiplying with the correct values, because if you make a mistake up here, you capture it even down here. Okay, so that is that. At this point, you can continue simplifying. You can now say nm is equal to, so 0 times 1 here will give us a 0, plus 1 times 2 there will give us a 2. Okay, 2 times 1 there will give us a 2, plus 0 times 2 there will give us a 0. We leave some space here, okay, to show that we are now switching to other entries. 0 times 5 there will give us a 0, plus 1 times 7 there will give us 7. Okay, 2 times 5 there will give us a 10, plus 0 times 7 there will give us a 0. You close, and then we can finish off by saying nm will be equal to 0 plus 2, 2, 2 plus 0, 2, 0 plus 7, 7, 10 plus 0, 10. That then becomes your final answer, and you are done. Okay, so here is another thing you need to take note of. When you're multiplying a 2 by 2 matrix, your answer should also be a 2 by 2 matrix. When you're multiplying a 2 by 2 matrix, when you're multiplying 2 by 2 matrices, your answer should also be a 2 by 2 matrix. I'll show you how you can check for the other matrices when you have different orders, like a 2 by 2 by, like this one here, this is a 1 by 2 times a 2 by 2. Okay, there's a way you can check whether, like in case you're not sure, sometimes the matrices look weird. Okay, you're used to multiplying 2 by 2, 3 by 3 matrices, and then you have something that looks different, like this one. How do you multiply? This one is quite easy. Let me show you something that may look different. Okay, this one here. Okay, this is where students get to have challenges multiplying such types of matrices, but I'll show you how you can easily multiply. So if both matrices you're multiplying are 2 by 2s, your final answer will also be a 2 by 2. Then for the other matrices, I will show you how to figure out the order of the final matrix. That way you may be given a guide on how to solve the question. Okay, so I don't see any hand raised or anything typed in the chat. I'll take it that there's no question. We proceed to the next question, which is coming from 2022 paper 1 GCE. This one was what? Paper 1 internal. This is GCE. Okay, so given that matrix C is equal to that matrix there, find C transpose. So what is our original matrix? We write down our original matrix, which is this one. We have 7, 1, 2, and then we have 3, 4, and 5. So what is going to be our C transpose? we said your rows become columns, right? So the first row is 7 3. All right, the first row is 7 3, meaning it's going to become your first column. So the first column will be 7 3. Your second row is 1 4 to become your second column. Did I say second row? Yeah, your second row is 1 4, it becomes your second column, 1 4. Your third row is 2 5, it becomes your third column, 2 5, and you are done. As simple as that, and you've earned yourself that 1 mark. Okay, we now proceed to the next question. Express as a single matrix. When they say express as a single matrix, they're simply asking you to multiply. So you're multiplying this matrix with that matrix. So you're going to say 1 8 and not 18 multiplied by matrix 0 2 -1 and 5. So sometimes in matrices they like giving you negative values because they know people have challenges with integers, and these are basics that you won't always learn online or from different people. I've noticed that people have challenges with integers because initially math, the foundation of mathematics is integers and order of operations, BODMAS. People can know how to solve, but if you have challenges, adding, subtracting, multiplying, dividing, integers, then you won't manage to get a distinction 1. So that is how come examiners like negatives, because they know negatives change things. Okay, -2 - 4. We know to say any subtraction. Remember -2 as my final answer, but it is wrong. Okay, they know to say if I put it this way, someone will end up adding. So they like negatives. If you check in exam papers, you see a lot of negatives everywhere. Even here they've put up a negative here to just confuse someone. So if you fall for that, you are not good at integers, you will become one of their clients. Okay, so when you have something like this, same principle again. At this point we only have 1 row, so it's just going to be this row by this column and then by that column. Remember, it is row by column, so meaning it's going to be 1 times 0 plus 8 times 2, and then we proceed to the other column. Okay, so let's say I'm not sure what the final order of the matrix will be. How can I figure out? Simply get the first matrix, list the order. What is the order? We said the order is given by row by column, right? How many rows do we have there? We have 1 row by how many columns? 2 columns, 1 and 2. That is the order of the first matrix. And then go to the second one. This one is easy because we know we have 2 rows and 2 columns, so it's a 2 by 2. Your resultant matrix will be this one here when you multiply. Okay, meaning it's going to be a 1 by 2. That's going to be my resultant matrix. So at this point, even when putting the bracket, I know to say I just have 1 row, so I can do that, and then I'll start multiplying. 1 times 0, let me remove these, they look like negatives. Okay, 1 times 0, I put it there, 1 times 0 plus, then I go to this one, 8 times 2, 8 times 2, then I leave some space because I'm now switching to the other column. Alright, so again it will be the same values from the first matrix. So I'm going to say 1 times -1, 1 times -1. You can list that like that, or you can say 1 times -1. It's one and the same thing. 1 times -1, then I say plus 8 times 5, 8 times 5, and I'm done multiplying the first matrix with the second matrix. At this point I can go ahead and simplify. So I'll say 1 times 0 is 0 plus 8 times 2 is 16. I'll leave some space simply because I'm switching to these guys. 1 times -1 is -1 plus 8 times 5, that is 40. So meaning my final order will be 0 plus 16, 16, and there what do you get? Positive 39. At this point, all of us should be good at integers. You always keep the sign of the bigger number. When the signs are different, you subtract, right? Yeah, so that will be my final matrix. And just as I found at first to say it's going to be a 1 by 2, indeed it is a 1 by 2. So in case you are confused, you can do some checks and balances. You can figure out what should be the final order of the matrix once I'm done multiplying, and that's how you can tell. Okay, let's now go to the next question. I don't see a hand raised, neither do I see anything in the chat, so I'll take it that there's no question. Okay, let's multiply this other matrix, which looks a bit different. So here we've been given matrix A. This came in 2024 GC paper 1. We've been given this matrix. Where is my pen? Okay, we've been given this matrix A as 2, -1, +3. We're now asked to find the transpose. So remember we said the row becomes a column. The row is 2, -1, 3, so meaning it's going to become our column like that. 2, -1 and a 3 down there. That means that is your transpose, and you have earned yourself that 1 mark. Okay, don't resent 1 marks. Yeah, this question just has 1 mark. Why should I even? No, those are the ones that actually make people pass. If a question is 3 marks, then you know it is tough. You need to earn the 3 marks. Most of the questions that have 1 mark, they don't even require you to use formulas. So make sure you hammer all these types of questions. If you go to vectors, the first 2 questions, even when you go to second theorem, you notice the first 2 questions are 1 mark each, but the third one is 2 marks. Why is it 2 marks? You need to think. Okay, you need to work hard for those 2 marks. So make sure 1 mark don't so do. You are hammering them mercilessly. Okay, so that is that. These, don't resent them. After 1 mark, no. Imagine you're about to get a 7 and you need just 1 mark to get a 6. Although I don't like giving such examples because they make people think as if I want students to be aiming for a 6. No. But just imagine, okay, you're about to get a 7. You need 1 mark to make it to 6. And then you just because in 1 mark you left the question. Just think about it. So you're going to make sure that you won't leave any tables unturned. There are also those of you who genuinely want a distinction. Imagine you are on merit, or maybe on distinction 2, you want distinction 1, you are just missing 1 mark, and then there's that 1 question you skipped because it was just a 1 mark. You end up getting a distinction 2 or a merit. So focus on these types of the questions. They are the simplest. If a question has little marks, just know that this one is very simple. Don't always aim for the big shots. No, I want this one that has 5 marks, this one that has 3 marks. That's what people want to aim for, so that you answer a few of those and you are good to go. But those ones, they will need you to put in effort. Alright? No wonder you notice this one is 1 mark, this one is 2 marks. Because of the amount of work you need to put in. Okay? So at this point, I want you to be aiming for a lot of these. And then you aim for these as well. A couple of those that you can manage. Yeah. But for you people, all the questions I'm teaching you should be aiming for all of them. Don't start choosing here. I've already chosen some vital topics, meaning there are some I've left. Then you also start choosing. You're not going to be safe. So here, there's no room for choosing. I've already chosen for you. You have no choice. You just have to know all these topics I'm teaching you. So that is that. We now come to the second one. We're asked to multiply. This is where students get to have issues. Okay, we're asked to multiply this one by that one. Okay, have you noticed how, due to us being used to patterns, was I always checking whether which one has to be in front? Okay, so that's what happens when you solve a couple of questions. You get used to the pattern, and then the examiner will just change the pattern, and then you fall for the odd pattern. Okay, so we have been given two matrices, A and B, and we're asked to find AB. So meaning this one times that one. So you list your matrices. 3 there, you have a 2 there. You close, multiplied by that one, which is a 1, -2. Okay, let's say I'm not sure. How am I going to multiply this one? What is going to be the resultant matrix? What is going to be the order of the resultant matrix? Let me list the order of the first matrix. How many rows does it have? It has 2. 1, 2. So I'll say 2 by how many columns? It just has 1 column. So 2 by 1. Then I go to the second matrix. How many rows does it have? It only has 1. Okay, so I'll say 1 by how many columns? 1, 2. I'll put a 2 there. Then I know to say, this one, when I solve it, I'm supposed to get a 2 by 2 matrix. Have that at the back of your mind. I'm supposed to have a 2 by 2. So meaning as you are solving it, you need to solve it in such a way that at the end, you get a 2 by 2 matrix and nothing else. Okay, so now let us see how we're going to multiply it. So remember, it is row by column. But now notice something different. In each row, you only have one entry. Remember I said when you have 2 or more entries in a row, that's when you need to add plus after multiplying. So since we only have one entry, it's just going to be 3 times 1. And you are done. Okay? 2 times 1. You are done. Nothing like putting plus. Okay? Then you go to the other column here. 3 again times -2. And then 2 times -2. This is where students get confused. When there's only one entry, there's no need for you to put plus. Please take note. Okay? You only put plus after multiplying when there's another, let's say there's another matrix, there's another entry there. So meaning it's just going to be, we know we've determined that's going to be a 2 by 2. So I can even draw the, write down the bracket like that. So I know it's going to be 3 times 1. Okay, 3 times 1. I'm done. There's only one entry there. I go to the next column. It will be 3 by -2. Okay, I'm done with the first row and all the columns on the right. Then I said these guys are multiplying with the same values, right? So here I have 3, 2. I have 3 already, so I just put 2 times the same entry. I go to the second one on the other side. Okay, so I have 3, 2 here. So I'm going to say 3, I put a 2 there, times the same value in the brackets. Okay, remember I said after the multiplication sign, you need to have the same values. You confirm that I've done the right thing. And then you proceed. What are we going to get? 3 times 1 there will give us a 3. 2 times 1, 2. 3 times -2, -6. 2 times -2, -4. We now have what we predicted. It's a 2 by 2 matrix, which is what we had predicted. So that's what you can do when you have strange looking matrices. And we are done. Okay, we go to the next one, and then we can go to these other weird ones. Alright, so this one they're asking us to find the transpose of matrix M. So matrix M has been given to us as -2, 4, 3, -2. Close. It's a 2 by 2. So M transpose will be equal to, the first row becomes the first column. So what is the first row? It is -2, 3. Becomes the first column. The second row is 4, -2. It becomes our second column, 4, -2. And we are done. Okay, we proceed to the next one, where they have given us matrix P and matrix Q. They're asking us to find PQ. So we're going to say PQ is equal to, we first list matrix P, which is 2, 0, -1 and 3. You close, and then you go to Q, which is -1, 3. So it's going to be row by column. So now take note here again, we only have one column in the second matrix. Let's determine what's going to be the order of the final one. The first matrix, matrix P, is a 2 by 2. We can clearly see that. The second one is a 2 by 1. So meaning our final answer should be a 2 by 1 matrix as well. Okay, we have determined that. I'll write it here, 2 by 1. So I know to say it's going to be something like this. So it's going to be 2 times -1, 2 times, or I can just put a bracket, -1, since it's a negative one number. Then I'll say plus, because there's another entry within that row. Then I'll say -1 times 3. Okay, so I'll put that one in brackets, -1. Let me write it properly. I can put the 3 there. Whenever you have a number right before or after a bracket, it simply means it's multiplying with that bracket, right? Okay, so I've put aside, I've put the -1 in brackets here to separate it from this operator down there. Okay, we go to the, so we are done with that. There's only one column, so I have 2, 0. I already have 2 there, so I'll just put a 0, and then I multiply it with the same value being multiplied with up there. And then here of -1, 3. So I already have a -1 there. I just have to put a 3, and then here I can say times 3. Since it is a positive, if you like, you can also put it in brackets. So now I can simplify. Okay, 2 times -1 is -2. Then they are going to say -1 times +3. That's going to give us -3. Okay, can close there. Then here 0 times -1 is 0. Okay, +3 times +3, that is going to give us +9 down here. Okay, there's no other entry. We can scroll down. So now we can say positive times the negative there to give us a negative. So it's going to be -2 minus a 3 there to close. And then here 0 plus 9 is just a 9. Okay, what do you get now? There we have -2 and -3. When the signs are the same, maintain the same sign, you add. So this is going to be our final answer, and we are done. Do we have any questions? Are there any questions? Okay, if there are no questions, that is nice. Great. All right, we proceed to the next example, which is this one. Given that A is this one. Wait, have I repeated this question? Yeah, I repeated this question, this one right here. I've just remembered that we did something like this. 2024 GCE paper 1. We did it up here. 2024 GCE paper 1. This one right here. Okay, so we can skip it. Alright, so now there are scenarios where you have different types of questions. This one came in 2020 paper 1 GCE. Okay, let's first of all find the transpose. They ask us to find the transpose of matrix C again. Usually we are used to finding the transpose of the first matrix. They have switched it to the last one. So first of all, list matrix C, which is going to be 7, 6, -1, 0. To find the transpose, what are we going to do? We're going to swap the rows with the columns. So the first row is this one, 7, 6. It becomes the first column, 7, 6. The second row is -1, 0. It becomes the second column, -1, 0, and you are done. As simple as that. Now there are cases where the examiner will give you two matrices, multiply them, give you the resultant matrix, but then hide one of the values. Okay, what are they saying here? Given that, let's focus on matrix A and B. Given that matrix A is this one and matrix B is this one, take note that this value is hidden. Okay, now they're asking us to find the value of x, for which AB, what does this mean? When you multiply matrix A and B, the final answer is giving you matrix C. So the final answer is this one. They've already found the final answer for you. So they just need you to figure out what is the correct value of X. So what are you going to do? You do the multiplication, okay? And also plug in the correct answer. So what we are going to do is we are going to list AB. So A, B, let's multiply them. Okay, so we are going to, A is what? 2, 3, 1, 0 multiplied by B. B is that one, negative 1 X in brackets also, and we have 0, 2. Okay, so now here is the thing. Let me show you something. When you multiply these two matrices, the final answer you're going to get is going to be C. So let me just put an equals here. What do you get for C? 7, 6, negative 1, 0, like that. So now here's the thing. This row multiplied by this column will give you the topmost value here. Okay, this same row by this column here will give you the topmost value there. This row down here multiplied by that column will give you this value there. This same row multiplied by that column there will give you this bottom number there. So all you are looking for is to form an expression so that you can be able to find X. So I'll simply focus on any row that's multiplying with this column. That's going to give me X, right? So I'll simply say this row by that column. I know to say when I multiply these, I'm going to get this value there, the topmost value on the left here. So I will simply do 2 times, okay, 2 times negative 1 there, so I can put the negative 1 in brackets, negative 1 plus 3 times X, 3 times X. What would that give me? To give me this topmost value there, which is a 7. And then I solve for X, as simple as that. So 2 times negative 1 is negative 2 plus, okay, don't make that a habit, the sign might change sometimes. Okay, let's say for example this X is negative, meaning it won't be a plus here. Okay, positive 3 times positive X will give us positive 3X. Then we're going to say 7. So we now group the like terms. 3X will be equal to 7 plus 2, because when this negative 2 crosses the equal sign, it becomes a positive. Then you're going to say 3X is equal to 7 plus 2, that will give you a 9. Divide both sides by 3, cancel that. The final value for X will be equal to a 3, because 9 divided by 3 is a 3. And you're done. That is your final answer. I hope that is clear. This is the one that is a bit different, so I need you to understand this one very well. Okay, let me just check the types of questions. The last 2 questions, these are the ones that are phrased this way. When did this come? This one came in 2024, so the likelihood that they might bring it again, well, you don't know, they might bring it again. The first one I could find came in 2020, and then this one came in 2024 for the grade 12s. Who knows, the examiner might bring something like this for you people as well. So since you can't determine what they'll bring for you, the only safety is in knowing all different versions of the questions. Now if you've noticed, we have different types of examples. This is to make sure that you know how to solve any version under matrices. That's the idea. Okay, we go to the next one, which is we're told to say matrix A is this one, find the transpose. So our A is equal to 4, 1, 5, 1. To find the transpose, we're going to swap the rows with the columns. What is the first row? The first row is this one, 4 5, becomes our first column, 4 5. What is our second row? It is 1 1, it becomes the second column, 1 1. 1 mark. We are done. So be careful with simple questions again, because the question seemingly is very simple. You're going to take it lightly. Like a question, and that's why we make mistakes. So be very careful with seemingly simple questions, because you will just want to rush through it because it is very simple and you find yourself making mistakes. So be careful with seemingly simple questions. That's how come you hear people saying, the exam was very simple, but then let the results come out, people have failed. Why? It's because they took it that this is too simple and they didn't even want to verify their work, and so they were just making silly mistakes, simple mistakes, and that's how they ended up failing. Okay, it happened for me in first year. Test 2, my aim was to get 100%. The test was so simple in my eyes, okay, or in my opinion. It was very simple that I didn't even want to review my answers and everything. It hits me up to date because I wanted 100%. We had some form of advanced probability, which was under mutually exclusive probability. The final answer was 3/15. Now, me being that was actually A intersection B, the probability of A intersection B. This was the final answer. Okay, Mr. Emmanuel, you remember, obviously we had that test in first year. That was test 2. Okay, this was the final answer. Okay, I solved it differently, but then me being a perfectionist, I put a therefore there. Therefore, the probability of A intersection B, all right, is going to be equal to, then what did I put? I put 3/5 instead of putting 3/15. And guess what? This answer, I was supposed to use it for the next question and the other question. So because I got a wrong value here, I ended up losing all the marks for these other 2 questions. And that's how I ended up getting, that was what, 70-something% out of 100. Just one simple mistake. I am thankful for that, because I was now angry, and there's this drive that I had which drove me to study even harder for the exam. Okay, because apparently in our class, people started studying for me because I had been topping all the tests in math, tests and assignments. So I was like, okay, let me now get 100% for them. Those kind of thoughts. Then what happened? I made a very small mistake, and it costed me my distinction, which I wanted in that paper. So what am I trying to say? Always confirm your work. If the paper seems too simple, be extra careful. Okay, you might not know. Examiners will just trick you somewhere and you fall for it. So if the question seems too simple, it's the one that needs your utmost attention. Okay, but generally all questions need your utmost attention. But otherwise, that's the thing. Always confirm your work. I learned it the hard way. My aim was to get 100%. I ended up getting 70-something%. And I was very mad. No, I need to see my script first. When I saw my script, I was humbled because I saw the mistake I had made. In my mind, I was just like, no, he marked my paper wrong. But then, yeah, that happened. So be very careful as you're solving. Okay, we now go to the last question, which is given that A is equal to that one and B is that one. Then they're asking us to find X if AB is equal to that one. So what they're simply telling you is that when you multiply matrix A with matrix B, your final answer is going to be that one. Now, find X. Okay, so what are we going to do? We're going to come up with, we are going to multiply these two matrices like this. So we're going to say AB is equal to, what is matrix A? Matrix A is this one right here, 4 1 1 5 1. What is matrix B? Matrix B is one that contains the X. We have X minus 1, and we have a 2 there, we have a 1 there, and we have a 0 there. Okay, so AB is going to be, we need to put an equals there so that we show the resultant matrix. What is the resultant matrix? It is 10 2 Remember, I was supposed to add some space, so let me scroll to the right. Sorry about that. Let me scroll a bit to the right. Okay, then we have 10, 2, 4, 1. 4, 1. What we have done here was simply showing to say when you multiply this matrix with that matrix, your final answer is what? This one. Now remember, I said you just need to come up with an expression which will contain an x, since you're trying to find the value of x. So you know to say this column, this row rather, by that first column is going to give me that top answer there. Okay, let me go over the other rows as well. This row by that same column will give me this bottom answer. All right, this is important because they might switch the value of x. It may be maybe somewhere else, so I need you to understand that. Okay, this row by that column will give me that top number. Okay, that row by the same column here will give me this bottom number. So you can simply focus on any that's going to contain an x. So we'll simply focus on this row by this column and then equate it to what? Equate it to 10. All right, and then we solve for x. So let's do this. We're going to say, no need for us to actually put the bracket, so just going to say 4 times this one. Because you have two values there, you are going to do it this way, x minus 1, because that 4 has to multiply with x and negative 1. That's why we put those values in brackets. We are now going to say plus. Why? Because there's another entry there, 5 times the 2 there, 5 by 2. What is it going to give us? It's going to give us this top number here, so we put a 10 this side, and then we solve for x. So I'm going to say AB. Okay, we can actually remove this because we're not finding AB. Okay, 4 times x is 4x. 4 times negative 1 is negative 2, negative 4. 4 times negative 1, negative 4. We come to this one, positive 5 times positive 2 is positive 10, which is equal to positive 10. So we're going to say 4x, we simplify these like terms here. What do you get? Negative 4 plus 10, that gives us positive 6, which is equal to a 10 there. Then you're going to group the like terms, so 4x is equal to 10 minus 6. This positive 6 has crossed the equal sign, therefore it has become a negative. So 4x is equal to 10 minus 6 gives you a 4. Then you're going to divide both sides by what? By a 4. What will be your final answer? So on the left, the 4's cancel, your x will end up being a what? A 1. So another thing that you might actually realize, okay, it's not always common, but sometimes you can see that this is making sense or this is not making sense. So what can actually give away a question to say it seems like I'm doing the right thing? You notice to say if you're finding the value of x, for example, in this question, and at the end you need to divide by another number, like here we have to divide both sides by 4, you find on the right side of the question a number that can exactly be divided by that number you're dividing with. So 4 divided both sides, there is a 4 here which can be divided by that 4. So it is rare that you find a fraction for these types of questions. So you can only figure that out after solving a couple of these questions. Otherwise, that is that under matrices, and we are good to go for any question on matrices in paper 1. We're just remaining with paper 2. So paper 2, usually they'll just ask you to find the determinant of a matrix, or they'll also bring something like this. They'll hide one of the values in one of the matrices and then they ask you to find the determinant. They'll hide one of the values, give you the determinant, and then ask you to find the determinant. And then finally they'll ask you to find the inverse of the matrix. That is how they usually phrase paper 2 questions. In all exam papers you're going to check currently, you'll see that format. It's either they give you both matrices and then they ask you to find the determinant, or they'll give you 2 matrices, hide one of the values in one, and then ask you to find the value which is hidden, but they also give you the determinant. And then the last question is always find the inverse of the matrix. So otherwise, paper 1, we are ready for matrices. Do we have any questions? Is it clear? Okay. If it's clear, we're going to go for a break. Then we'll come back and look at eighth geometry. So our break is going to be 11 minutes. This is 17:09. So at exactly 17:20, we are going to start looking at eighth geometry. So make sure you're back early. Don't delay. All right, I'll be back in 11.